Hello class, welcome to the first lecture on programming in C. So in this lecture we'll be dealing with some of the basics of computer, and briefly we will just discuss some basics of computer, and then we'll move on to the computer organization part that you have. We have already discussed the syllabus in our first session, so we'll right away jump into the topic. Okay, so first of all, what is a computer? What is a computer? Actually, you are viewing this lecture itself from a computer, right? Maybe a desktop, it may be a laptop, it may be a mobile phone. Either way, it is a computer. So depending on whom you ask the question, you will get different answers regarding what a computer is. But all of those answers, or at least most of those answers, will be based on the utility point of view. That is, okay, it is something used for this and that. But from an engineering point of view, or from the point of view of this particular course, we can describe a computer as a black box. Let's call this as a computer. Okay, this is a box, whatever it may be. So it gets some input and it gives some output. Okay, suppose when you are watching this video from YouTube, what is actually happening? You are getting the input from the internet. You have some internet connection provided by some provider that is connected to your phone. You get the internet using Wi-Fi or mobile data or whatever. That whatever data is coming, it is converted into video or video and audio, and you are seeing that. So whatever is coming from the internet, that data is the input, and the output is whatever you are seeing and hearing. Okay, so that is a very bird's eye view of the thing, the process. Okay, so this is not just happening right away, or maybe from a simple very simple point of view, you can say is that, okay, you have some inputs A and B, you give it to a system, and output is A plus B. And this system, let's say it is as a processor, this processor is doing some sort of arithmetic operation. Okay, so whatever you are seeing, whatever operation you are doing on a computer, it can be broken down finally into a finite set of operations, most of which are what, arithmetic or logical operations, addition, subtraction, logical and or anything like that, something like that. So basically you have some input, you have some output, and some operation is being done on that based on what. You cannot just simply, the computer won't do some operation, it will be based on some sort of instruction. Okay, so this is what you can say a very rudimentary or very abstracted look into a computer. That is, you have an input which you can call as the data, and you will do some sort of process on it, and you will get some output which is some sort of information, let's say. Okay, and whatever you are doing, what operation you are doing on it, it is defined by the instruction that is given to the computer. So who gives the instruction? It can be the user, it can be some developer who gave it, anyone, like someone like that. That is, so this is the basic operation, basic let's say view that you should have regarding a computer when it comes to our perspective. That is, it is a machine which can take some input and give some output, and what is the output? It will be obtained after receiving or doing some sort of operation or process on the input based on an instruction given by the user. Okay. Now coming to the components, right? So whatever it is there, whatever is required to run a computer or whatever is required to operate a computer, you can divide it into two parts, which is the hardware and the software. Okay, both of which are parts of the computer. Then there is something called as a firmware. Okay, so what is a hardware? It is a physical components of the computer. Okay, physical components of the computer. What do you mean by physical components of the computer? Suppose the computer that you're seeing, if suppose you have a desktop, what do you have? You have a monitor, you have a keyboard, you have a mouse, you have a speaker, you have a webcam. Those are the things that you see, right? Then when you go into the computer, what do you have? You have a motherboard, you have an internet card, you have a fan, you have a processor, the most important thing, you have a RAM, you have a hard disk. So many things are there. But for the point of view of this course, for the sake of ease, what we'll do is we'll divide them or we'll group them into certain things. So what do we have? And this will follow this point of view, this division, whatever division of hardware I'm going to say, it will follow this point of view. Okay. So first thing is, what do you have? You have input devices. What are input devices? You have your mouse, keyboard, whatever. That is whatever is used to transfer data into the computer. Okay. Then you have your processor. It is called as the CPU, Central Processing Unit. We'll come to that. Okay. But in modern systems, processor is not a standalone device, right? Even in your desktop or your laptop, you will have something called as a motherboard, which is a support mechanism used to support the processor, because a processor by itself is useless. You cannot just plug in a processor into something and use that. So, to use the processor, it requires some support mechanism, and that is provided by what we call the motherboard. Right. Then we have the output devices. So input devices I will mark as I bar P, and output devices I will mark as O bar P, and input and output devices combined sometimes I will mark as I bar O. Just remember this. This is input output, this is input, and this is output. And hardware, it will be shorthand, will be used H bar W. Okay. So we have the input devices, multiple. We have the processor and its support mechanism. We have the output devices, right? And then we have the memory. So memory will be there will be primary and there will be secondary memory. So from here you can see we have the input, we have the processor, we have the output, and where this memory come into play? Actually, this memory is where these instructions are residing. So memory is used to hold instructions and also sometimes data. Sometimes this data, it can come from it need not always come from some sort of input device. It can come from the memory itself. That is, along with the instructions, we will be storing some sort of data which is useful for executing some instructions. Okay. Then we have software. So what is software? Software is basically collection of instructions, used to make the hardware perform certain tasks. That is software. We have, like I mentioned here, that we store instructions in the memory, right? So suppose you may be watching this from your browser, right? You may be watching this from your YouTube using your browser. So what is the browser? Basically it is a software. It is an application software. That means it is a collection of instructions. It is a bunch of so many lines of code written in some sort of programming language, like C that we are going to learn. Okay, it will be written in some sort of programming language, and some process is done to that, and that is being executed by the hardware. So basically you cannot just, you need some instructions to make use of the hardware, right? That collection of instructions which perform a particular task. For example, you are using a browser software for browsing the internet, for gathering data and presenting it to you in a legible form. That is the purpose of a browser software. Similarly, you will have n number of softwares for multiple purposes. So that is a software. And there is a classification of software is system software and application software. So basically, what is a system software? System software is the layer of software which directly interacts with the hardware. For example, your operating system is a system software. That is the software which is used to manage the hardware. Okay. Used to directly manage the hardware. And what is application software? Application softwares are softwares which you use for your certain purpose, like your browser. So an example for system software is your operating system, right? Your OS, Windows, Ubuntu, whatever maybe. Application softwares are specific softwares for specific purposes, like your browser, media player. Okay, like that. So the thing with and where it is stored, it is permanently stored in the secondary storage. We will come to the types of things, or secondary memory, and whatever instructions you have to perform in the processor at any given time, it is done by copying it to the primary memory and then using the processor. Will come to that. Okay. And what is firmware? Firmware is like, for example, hardware is the physical part. It is not changeable every time. And software, it is stored in the data storage or memory, and you can change it however much you want. But firmware is something in between. It is sort of a semi-permanent storage, right? So usually firmware is stored in your ROM, and it is used for your things like your BIOS and your boot up, right? Things like that. That is, it is changeable, but you don't usually change it always, right? A sort of a semi-permanent thing. It is a software only, but you don't change it usually. Okay, it is a bunch of instructions, set of instructions only. set of instructions and data. Okay, so it is something in between hardware and software. So the next topic that we have to go through is we'll dive a little deeper into the functional view of a computer and the different let's say block diagrams and different components, hardware components of a computer. So we'll do that in the next lecture. So what have we learned in this lecture? We just went through what a computer is, what sort of view that we'll be holding in this course, and then we just mentioned 3 terms: hardware, software and firmware, and we just briefly went through what those are. So in the next lecture we'll be focusing mainly on this hardware, and after that we'll briefly go through the software aspect. We won't be touching upon firmware, and once we are completed with that, we'll be moving on to the programming part. Okay, thank you.